Okay, we're looking at the 7C test today. First question says a random variable y has the following distribution. And the probabilities here, we have some unknowns. For -1, we have 3C, and for 0, we have 2C. So what we need to do here is think about the fact that the probabilities of some event happening are always all going to sum up to 1. So over here on the side, I know this is kind of blurry, but what I did is I did 3C plus 2C plus the 0.4 plus the 0.1, and it set it equal to 1. And basically then just solved for C, and I got C is 0.1, and so the answer to number 1 is A. Number 2, a random variable x has a probability distribution as follows. And again, we have a bunch of variables here. So first thing I looked at was I found the total amount of k that they have, and it adds up to 20k. The question wants to know the probability that of the x being less than 2. So in this scenario, in order for x to be less than 2, it can only be 0 or 1. So I did 2k plus 3k, that gave me 5k. 5k out of the total 20k is 1/4, which is 0.25, so the answer is B. For number 3, it says cans of soft drinks cost 30 cents in a certain vending machine. What is the expected value, or the mean, and variance of daily revenue y from the machine if x, which is the number of cans sold per day, has an expected value of 125 and a variance of 50? So this problem right here, the fact that the soft drinks cost 30 cents, that's going to be a B. That's like a transformation of our values. So we know the expected value for x and we know the variance for x, but we need to figure out what those things would be for y if they're selling each of those cans for 30 cents. So the first thing I'm going to come up with is that y is b times x. And so to find the mean for y, I have to use the formula, which would tell me that the mean of y is b times the mean of x, which would be 0.3 times the 125, the expected value, which gives me 37.5. And to find the variance for y, one of the formulas from the notes again tells you that the formula is b squared times the variance of x squared. Not the variance squared, just the variance. So we have b squared, which is 0.3 squared, times the variance, which is 50. That gave me 4.5, so my answer again is B. For number 4, it says a rock concert producer has scheduled an outdoor concert. If it is warm that day, she expects to make a $20,000 profit. If it is cool that day, she expects to make a $5,000 profit. And if it's very cold that day, she expects to suffer a $12,000 loss. Based upon historical records, the Weather Office has estimated the chances of a warm day to be 0.6, the chances of a cool day to be 0.25. So therefore, we need to find the chances of it being a very cold day also. And they want us to find what is the producer's expected profit. So we're looking for the mean value here. So the expected value, the mean value, is each expected profit times the probability of that type of day happening. So $20,000 profit times 0.6, because there's a 0.6 chance of it being warm, plus a $5,000 profit times 0.25, the chance of it being cool, and then we have a $12,000 loss. So that's minus 12,000 times 0.15, and over here it says because 0.6 plus 0.25 plus 0.15 is equal to 1. So if you just dump that calculation in your calculator, you will get 11,450, which is E. Okay, moving on to number 5. It says, in a particular game, a fair die is tossed. If the number of spots showing is either 4 or 5, you win $1. If the number of spots showing is 6, you win $4. And if the number of spots showing is 1, 2, or 3, you win nothing. Let x be the amount that you win. The expected value of x is what? So I made a little table here. I think I kind of have it labeled wrong because x should be the amount that we are winning, and I have x being what you roll on the die. But we know that the probability of each of these things happening is 1/6 because it's a fair die. And then I have a category for how much you win, and then correlated it to the events that are in the problem. So my expected value is the probability of each thing happening times the winnings that you would make, which is just 1/6 times 0 plus 1/6 times 0 plus 1/6 times 0 plus 1/6 times 1 plus 1/6 times 1 plus 1/6 times 4. You do all that, you will get $1. So essentially, in this kind of scenario, they're not asking about this, but if the game costs more than $1 to play, you shouldn't be playing it, because on average you will lose money if you're paying more than $1 to play the game. Question 6 says, suppose x is a random variable with mean mu x and standard deviation sigma x. Suppose y is a random variable with mean mu y and standard deviation sigma y. The mean of x plus y, this is a formula, is mu x plus mu y. Pretty sure this is right. I will leave a note if I am wrong about this. It might be C. I'm pretty sure I checked the answer and it was A though. But now that I'm recording the video, I'm confused. So sorry about that. But I'm pretty sure it's A. For 7, the variance of x plus y is sigma of x squared plus sigma of y squared. And that's only if x and y are independent. So 7 is D. Again, those are just pulling formulas straight off your notes. Question 8 says, suppose x is a continuous random variable taking values between 0 and 2 and having the probability density function below. In order for it to be a density function, that means the area under the curve is 1, so let's make sure it's 1 first. This is a triangle shape, the whole thing. The base is 2 units, the height is 1. Area of a triangle is 1/2 base times height, so 1/2 of 2 times 1 obviously is 1, so this is an okay density function. They want us to find the probability that x is between 1 and 2, so you should sketch a line from 1 up to your curve, and we're finding the area between 1 and 2. So between 1 and 2, again, we have a smaller triangular shape. The width is 1 unit. The height, because this is halfway, would be 1/2. So my area is 1/2 times 1 times 1/2, which gives me 1/4. So the probability that x is between 1 and 2 is 0.25. Okay, question 9 says, Picard Partners is planning a major investment. The amount of profit X is uncertain, but a probabilistic estimate gives the following distribution in millions of dollars. We need to first find the mean profit mu X and the standard deviation of the profit. So again, my mean is just each profit times the probability of it happening. You sum it all up, and you will get 3 million. The standard deviation would be the individual value minus the mean. So we'd have 1 minus 3. This is a -2 here. You're taking that thing, you square it, you multiply it by the probability of it happening, 0.1. Then you're summing all of them up. So plus the next one, 1.5 minus 3 gives me -1.5. We're squaring it, multiplying it by the probability of 0.2. The next one, 2 minus 3. I've got a -1 here. We're squaring it times the probability, 0.4, etc., etc., etc. Go through all the probabilities. You sum that all up on your calculator, and you take the square root, and you get 2.519 million. Part B, Picard Partners owes its source of capital a fee of $200,000 plus 10% of the profits, X. So the firm actually retains y equals 0.9x minus 0.2 from the investment. Find the mean and standard deviation of y. So this is where we're going to do a transformation. So the mean of y is, I just flipped the order of these around, -0.2 plus 0.9 times the mean of x. The mean of x was 3. You plug in 3, you will get 2.5 million. The standard deviation for y, again, the formula is off of your note sheet. The formula uses variation, so it doesn't have the square root over here. It has this side squared, so you have to take the square root of both sides. But then it's b squared, and b is my 0.9, so 0.9 squared times the variance of x. The variance of x is just 2.519 squared. You multiply those together, take the square root, you get 2.767 million. Now that might be 2.2. I can't read my handwriting, but you can calculate that on your own and just check and see if that's a 2 or a 7. But that's the process you do for part B. Question 10. This is the question that has a tricky part to it. It says the Census Bureau reports that 27% of California residents are foreign born. Suppose that you choose 3 Californians independent of each other and at random. There are 8 possible arrangements of foreign and domestic birth. For example, FFD means the first 2 are foreign born, while the third is not. The third would be domestic. Part A, write down all 8 arrangements and find the probability of each. So I put down all 8 arrangements. The probability of each one of these things happening is 1 out of 8. Part B, let the random variable x be the number of foreign-born people in each group of 3 Californians. What are the possible values of x? First thing, possible value of x are 0, 1, 2, or 3. Second part, use the probabilities you found in A to construct a probability distribution table for x. We know our probabilities should sum to 1, but this is the tricky part here. So if there are going to be 0 foreign-born people, I'm going to first look at how many different arrangements are there where there's 0 foreign-born people. Well, I see there's 1 out of 8 foreign-born. 1 out of 8 times there's foreign people. So the way you do this, let me bring this over here so we can see this a little bit better. Okay, on the side it says, since 27% of the Californians are foreign, the probability of being foreign is 0.27 and domestic is 0.73. It's not a 50-50 chance of being foreign or domestic in California in this scenario. So the way that we calculate the probability of there being 0 foreign-born people is not just, oh look, there's one time it happens out of 8. So it's not just 1 out of 8 right here. The way you do it is you have to find the probability of being foreign. Well, in this case, because there's 0 foreign people, that means there's 3 domestic. So the probability of being domestic would be 1 minus the 0.27, which is 0.73. And there's 3 domestic people in that scenario. So you do 0.73 to the 3rd power, and you get 0.389. To find the probability of 1 foreign-born person, we would come over here and say, okay, look, here's one event where there's 1 foreign, here's a second, here's a third. There's 3 out of 8, or there's 3 times where there's an arrangement of 1 foreign-born person. So the way you calculate that is there's 1 foreign, so 0.27, there's 2 domestic, 0.73 squared. You multiply those together. But then because there are 3 possible ways that that could happen, where there's 2 domestic and 1 foreign, you're multiplying your answer by 3, and you get 0.4316. To find x is 2, again, where there's 2 foreign-born people, there's 1 way, 2 ways, 3 ways that there can be 2 foreign and 1 domestic. So there's 2 foreign people, so 0.27 squared times 0.73, the 1 domestic person. Whatever that number is, you're going to multiply it by 3 because there's 3 ways it could have happened, and you get 0.1597. And then the last one, if there's 3 foreign-born people, there's only 1 way it can happen. So you're doing 0.27 to the 3rd, and because there's 1 way, you're multiplying that by 1, which is why I'm not showing that. When you do 0.27 to the 3rd, you get 0.0197. If you check all these probabilities and sum them up, you will get 1. We're going to pause here because I'm running out of recording time and pick up with a second video.